After talking about principal stresses and principal planes as well as the transformation equations, let's combine all what we have learned into a new concept which is called Mohr circle. Here are the two transformation equations we get previously. For the shear stress transformation equation, we call it number 1. For the direct stress transformation equation, we call it number 2. And we do a little bit modification on the transformation equation of the direct stress. That is, we put this term on the left hand side. So originally, it is something like sigma x1 equals to sigma x plus sigma y divided by 2, and the plus sigma x minus sigma y divided by 2 cosine 2 theta plus tau xy sine 2 theta. Okay, so we just put this term to the left hand side to get number 2. Now what we have to do is that we square both of the equations and add them together. Then for equation 1, you will get tau x1 y1 squared equals to tau xy squared, tau xy cosine 2 theta sine 2 theta sigma x minus sigma y plus sigma x minus sigma y divided by 2 squared sine squared 2 theta. Okay, this is 1 squared. For 2, equation 2 squared, it will become sigma x1 minus sigma x plus sigma y divided by 2 squared equals to sigma x minus sigma y divided by 2 squared cosine squared 2 theta plus tau xy cosine 2 theta sine 2 theta sigma x minus sigma y plus tau xy squared sine squared 2 theta. Then for the left hand side, it is combined to be something like this. So sorry that here it should be cosine 2 theta squared. Okay, so I missed this term. So for tau xy squared, we first take out tau xy squared, and then we combine those two terms together. Then we have something like this. And obviously you can observe that this term automatically becomes 1. For sigma x minus sigma y squared divided by 2, this term, you can also group them together. Here is sine squared 2 theta, and here is cosine squared 2 theta. Then those two added together equals to 1. At the same time, we observe those two terms are exactly the same except the symbol. That is, those two terms are placed here and being vanished to be 0. Then, after we do a lot of simplification, you can have tau x1 y1 squared plus sigma x1 minus sigma x plus sigma y divided by 2 squared equals to tau xy squared plus sigma x minus sigma y divided by 2 squared. So here, this stuff is just r squared. Okay. At the same time, we define the average direct stress to be sigma 1 plus sigma 2 divided by 2, which is the average of the principal stresses. But just now, we also discussed that sigma x plus sigma y equals to sigma 1 plus sigma 2. So here we discussed that for any angle of inclination, the sum of the direct stresses are always the same. The same also applies to the principal stresses. Then this term will become sigma average. Then what to left here is this equation. Sigma x1 minus sigma average squared plus tau x1 y1 squared equals to r squared. Notice that it is a constant. Okay, r squared is also a constant. Notice that here sigma average is a constant, r is also a constant. The variables inside the circle are sigma x1 and the tau x1 y1. Then you can observe that it is an equation of circle. The Mohr circle has a center located at sigma average 0 with the radius r. By using your knowledge you learned in the secondary school about the equation of the circles. And recall that r equals to this stuff. In summary, when you want to draw a Mohr circle, bear in mind with the center and the radius. For a Mohr circle, there are two ways that we can draw it. One is the ordinary coordinate system, something like sigma x1 and tau x1 y1. However, we seldom use this in the solid mechanics course. It is because 2 theta is positive in counterclockwise direction as what we defined at the beginning. It is exactly the direction we adopted when we deriving the transformation equation. So the reason why we don't adopt this is that if we adopt Mohr circle like this, then the direction of 2 theta will be like this, which is not what we want. What we want is the Mohr circle like this, tau x1, y1, and sigma x1. Then the Mohr circle constructed in this coordinate system will have 2 theta positive in this direction.